to inclusion and empowerment. We are one of the largest consumer of data per capita, and we continue to grow. Second, we are paving the way for India to lead the next technology revolution. We are on our way to connect 600,000 villages with broadband. We are investing in developing capacities in 5G, IoT, and clean energy technologies. We are working to unleash the next wave of innovation in data, AI, and other technologies. Third, India is headed for robust economic growth. We have the world's fastest growing startup ecosystem. New unicorns are coming up every few weeks. India's own consumption of semiconductors is expected to cross $80 billion by 2026 and $110 billion by 2030. Fourth, we have undertaken wide-ranging reforms for improving ease of doing business in India. Last year, we abolished more than 25,000 compliances and gave a push towards auto renewal of licenses. Similarly, digitization is also bringing speed and transparency to the regulatory framework. Today, we have one of the most favorable taxation structures in the world. Fifth, we are investing heavily in skilling and training young Indians for the needs of 21st century. We have an exceptional semiconductor design talent pool, which makes up to 20% of the world's semiconductor design engineers. Almost all of the top 25 semiconductor design companies have the design and R&D centers in our country. And sixth, we have undertaken several measures toward transforming the Indian manufacturing sector. At a time when humanity was fighting a once-in-a-century pandemic, India was not only improving the health of our people, but also the health of our economy. Friends, our production-linked incentives schemes offer incentives of over $26 billion in 14 key sectors. Over the next 5 years, the electronics manufacturing sector is expected to see record growth. We recently announced Semicon India program with a total outlay of over $10 billion. This program aims to provide financial support to companies investing in semiconductors, display manufacturing, and design ecosystem. We are aware that in order for a semiconductor ecosystem to flourish, it is necessary to ensure adequate support from the government. Allow me to put our approach in the language of semiconductors itself. In earlier times, industries were ready to do their work, but the government was like a NOT gate. When any input flows into the NOT gate, it gets negated. So many needless compliances and no ease of doing business. But We understand that the government must be like the end gate. While the industry works hard, the government works even harder. I would like to assure you that we will continue to support the industry in future as well. We have taken care to see that the Semicon India program addresses various parts of the ecosystem such as semiconductor fab, display fab, design, assembly, test, marking and packaging of semiconductors. Friends, a new world order is forming and we must seize this opportunity. We have worked hard over the last few years to create an environment that encourages growth. India had the appetite for tech and risk taking. We have put the odds in your favor as far as possible through a supportive policy environment. We have shown that India means business. Now it is over to you. Friends, I look forward to practical suggestions from all of you about how we can move towards an India that is hub for semiconductor for the world in the coming years. Through this conference, we aim to engage with domain experts. We will work with stakeholders to understand what more can be done to build a vibrant semiconductor ecosystem. I'm confident that this conference will have rich deliberations which will help steer India into a new future. Thank you. Thank you very much.
Be partners in the journey to catalyze the Indian semiconductor ecosystem. The theme for this first Semicon India conference, as you all know, is catalyzing the Indian semiconductor ecosystem. And that statement maybe needs some explanation and expansion. And let me, in the few minutes that I have, lay out for your consideration and thought what this India's ambition means and what our Honorable Prime Minister's vision points to. Firstly, a little bit of a backstory. I think we will all accept and recognize and acknowledge that we are all emerging from the worst ever black swan type event that has been forced on the world in modern history. Every country and all the people all over the world had to deal with this COVID pandemic. Livelihoods and economies were battered by this unknown virus. And every nation has found themselves operating blind or flying blind. And in aviator parlance, It's flying VFR and an IFR weather, as every pilot calls it. And every nation has traveled through these 2 years differently and emerged, in my opinion, very differently. I don't want to comment on other nations, those who are still struggling with lockdowns and shutting down large cities, those who are struggling with vaccinations. I don't want to comment on which those countries are, but you know who I refer to. But I will simply put this to you, that India has emerged from these last 2 years a very different and a much stronger nation. We, in the first quarter of the pandemic, had to lock down, had to deal with very severe economic consequences of that lockdown, and for that year had to deal with almost $150 to $200 billion of economic losses. While for large major economies in the West and maybe other countries, a $200 billion economic loss is not a big thing. For India, a growth economy, a $200 billion economic loss is a significant issue, not just in terms of the number it represents, but also in terms of what it does to the trajectory of growth. Despite that, and despite the ominous, all-pervading nature of the pandemic, India in these 2 years has shrugged off that economic loss, is today the world's fastest growing economy, and has demonstrated during these 2 years the things that it can do at scale. 1.8 billion vaccination shots in probably one of the largest, most effective vaccination programs in the world. Those vaccines designed, developed, and manufactured in India. 800 million Indians in one of the world's largest food distribution programs that has lasted over 2 years. That is social security at scale. And creating a momentum and a rebound of the economy post the pandemic, the size and scale and momentum of which the world is in awe of. I personally, as somebody who's been an entrepreneur before I entered politics, have total respect and admiration for in terms of what is going on today. And the Honorable Prime Minister referred to this. The unicorns that are coming out, the extent of foreign investment that is going into our tech economy and digital economy, and all of that. And most importantly, it is showcased to the world that old narrative of India being a dysfunctional democracy where the government doesn't function, citizens are at odds with government, it has in a sense turned that entire narrative on its head and said, India is a country that can do things at scale, take on adversity, bounce back from that adversity, demonstrate the strength of its economy, and government, citizens, state government, national government, science and technology can all be deployed to come out of these serious challenges. And I mention this because in today's social media-driven world, instant gratification, quick news, there is a tendency to forget and move on. And I want to especially bring this point to you in the context of this discussion on semiconductors and semiconductor ecosystem. On the digital economy, our Honorable Prime Minister has laid it out. Minister Vaishnavji has also spoken about it. Our ambitions are very clear. You are all aware that in this post-COVID world, the acceleration in terms of the digitization of the world's enterprises, consumers, and governments are at an unprecedented pace. You can see the tech economy in India has grown last year 16+% on a base of 250 billion. And this is all, in a sense, a continuum. Over the last 7 years, after Prime Minister Modi launched Digital India, the digital economy piece of the Indian economy has been constantly growing. It started with the traditional tech services piece. You can see the great success we've had on the internet economy. Now we are building the AI and data economy piece on top of that. The electronics piece, as you've also heard, is fast growing. And as a natural progression, we are now moving into catalyzing the semiconductor ecosystem. I wanted to tell you this because unlike countries and unlike some other places that think semiconductor is the fashion of the month, the flavor of the month, for us in India, the approach to catalyzing the semiconductor ecosystem, seeking out its growth, seeking out the expansion, is a very, very calibrated strategic roadmap of growing the digital economy into a $1 trillion digital economy by 2025-26. The Prime Minister has referred to this as the India's decade, the next 10 years. And recently, one of the most important semiconductor CEOs that I know of visited India and tweeted and referred to the coming decade as one full of opportunities for India. And that is India's decade. That is the future that we are building the semiconductor ecosystem for. I'll just, before wrapping up, just leave this other thought with you. And the details of the semiconductor policy, Minister Vaishnavji has already laid out. The decade in India is being driven, and this is an important aspect of our expectations, is being driven, built, catalyzed, energized by thousands of startups around the country. And it is in this ecosystem of innovation that needs to be connected to the semiconductor space and vice versa, to shape the future of the semiconductor ecosystem for the world. And really, India is now, as the Honorable Prime Minister said recently in the World Economic Forum, India's ambition is to grow and become a significant trusted source of digital products, digital services, and digital talent for the world. Our goal is to address innovation and performance, the entire semiconductor ecosystem, from design to packaging to fabs, to span silicon and compound, and to create prime movers investments in each of these areas. And India's ability to do this will be in a lot of ways driven by our engagement in this conference and our conversations going forward. Before I end, the question that I'm posed when we pitch to these semiconductor majors or to anybody who's a participant in this ecosystem is, can India do this? And my answer, and I hope all of your answers at the end of these 3 days will be, yes, we can do it. Yes, we will do it. And it's a question of us working together, and to use a phrase that the Honorable Prime Minister says, Sabka Saath, Sabka Prayas. If we work together and cooperate together and work to this common vision, we can realize that goal. I'll end by saying this. We are living in exciting times. I surely believe it, and I hope all of you do, that Prime Minister Narendra Modi's government is determinedly ensuring that every opportunity in front of India is translated into real opportunities for India's youth and for India as a country. I hope today, with our conversations and over the next 2 days, we will contribute to that goal and the Prime Minister's vision. Thank you all again for being here. Thank you. Jai Hind.
Thank you, sir, for words of encouragement and also giving a new sense of confidence in the entire fraternity. Let's all once again thank Shri Rajiv Chandrasekhar ji for your address. Thank you very much, sir. Well, ladies and gentlemen, we are all now heading towards 3 back-to-back keynote addresses, 2 on the virtual mode and 1 in the physical mode. The first keynote address will be by Mr. Sanjay Mahirotra from Micron Technology. As we are all aware, he's the most prominent techno-business global leader in semiconductor memory technology. He co-founded SanDisk, Fortune 500 company from a startup, leading Micron technology since 2017 and guiding it to its glory. Well, before the keynote address of Mr. Sanjay Mahirotra unfolds, we'll get a brief introduction, a brief insight into what Micron Technology's vision is all about. So it'll be followed by the keynote address. Let's have the video, please, first.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. Feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
Micron is where data lives.
Namaste and good morning. Honorable Prime Minister Shri Narendra Modi ji, Shri Ashwini Vaishnav ji, Shri Rajiv Chandrasekhar ji, center and state government officials, colleagues from the industry, from academia, members of the press and students. It is an honor for me to deliver the keynote address today. Today's economy is unquestionably based on data, driven by the innovative technologies that make that data more accessible, more effective, and more useful. McKinsey projects that data-driven artificial intelligence technologies will add $13 trillion to the global economy by 2030. All that added value is driven by our ability to make better and faster decisions based on the information all around us. Data is the fuel of our global economy and touches nearly every aspect of our daily lives. That fact is driving a technology revolution, and semiconductors are at the center of it. Semiconductors are the brains of modern electronics, enabling advances across communications, computing, industrial, automation, healthcare, education, transportation, every sector that you can imagine. The semiconductor industry is projected to be a $1 trillion market by 2030. It is growing exponentially, and the data economy is the driving force. But let's talk about what is maximizing the value of that data. Memory and storage are now truly essential and can be found anywhere that data is stored or processed: smartphones, automobiles, personal computers, and data centers. Memory and storage technologies have become central to computing architectures and future innovation, meaning they are also critical to the world's core infrastructure. We have seen phenomenal revenue growth from the PC internet era through the shift to the smartphones and on to today's growing data economy. And we see memory and storage becoming more and more central to enabling transformational future innovation. The importance of memory and storage is clear when you look at trends in our industry. As the value of fast data access increases, DRAM and NAND revenue growth are outpacing the broader semiconductor industry. Customers are demanding platforms with higher densities of advanced memory and storage technology. While DRAM and NAND used to be about 10% of semiconductor industry revenues, they now represent 3 times as much. According to Gartner, in 2022, memory is forecasted to account for more than 30% of the $639 billion overall global semiconductor market. And memory and storage account for the majority of semiconductor wafer production as well. Nearly 60% of all silicon wafers produced globally today are for memory and storage. Data-driven applications are creating that growth. Secular drivers like pervasive and ultra-fast 5G networks and advanced artificial intelligence systems are expanding the use of memory and storage across the data center to the intelligent edge and on to billions of connected devices. Part of what makes this rapid growth possible are the dramatic advancements the semiconductor industry has driven in DRAM and NAND technologies. Over Micron's history, we have evolved DRAM from 64 kilobits to 64 gigabits. 1,000,000 times the data density increase in the same tiny package over just 4 decades. NAND has been on a similar journey, but in a slightly more compressed timeline. In NAND, we moved from 8 megabit parts to a die that can hold a terabit of data. We achieved this by moving to complex 3D designs, hundreds of layers deep, with the capability to differentiate 4 bits in each data cell. We made similar progress on cost efficiency. Consider these two charts. The development pace for memory and storage has been a turbocharged version of Moore's law, even if we are just considering the last 15 years. The advancements in DRAM have reduced the cost per gigabyte to a fraction of what it was in 2006. For NAND, the curve is even steeper, with a 99% reduction in cost per gigabyte. Those advances have required tremendous innovation at a fast pace. Innovation in performance, density, cost reduction that are opening up new, more diversified markets. Memory really is at the leading edge of semiconductor manufacturing. Data centers, intelligent edge networks, automotive, and industrial devices are all high-growth areas with tremendous demand. Two of the most critical innovations fueling the data economy are AI and 5G networks. AI, the most disruptive workload class in the history of computing, fundamentally redefines the insights we can extract from data. The rise of AI has been fueled by the combination of massive amounts of data and massive amounts of computing resources, and the industry is rapidly advancing AI capabilities to provide new and greater value. While AI is disrupting the world's applications, 5G networks are unleashing data movement, embracing low latency and enhanced mobile bandwidth, and delivering the same cloud-based scale and capacity that is found in the world's data centers across the communications networks. Memory and storage's share of the server bill of materials already exceeds 40%, and that share gets even higher for servers optimized for AI workloads. This growth is supported by new heterogeneous computing architectures, the increase in data-intensive workloads, and the ongoing displacement of hard drives by SSDs. And the explosion of data is not limited to traditional applications. In fact, by 2025, 75% of data will be generated and processed outside of data centers. Data is being captured and processed closest to where it is needed in order to derive and act on insights in real time. Smartphones, automotive, industrial, and communications are driving some of the fastest annual growth rates in the industry. GSMA estimates that 5G applications will help bridge the rural and urban healthcare divide in India and create billions of dollars of socioeconomic benefit through applications such as telemedicine, precision medicine, and remote surgery. We see growth in 5G devices too. 5G phones today have 50% more memory and double the storage content compared to 4G phones, content that is used to drive increasingly complex applications. The third pillar of the future digital economy is autonomous. We already see semi-autonomous electric vehicles using memory content similar to a data center server. I like to call them data center on wheels. Electric vehicles are rapidly growing in popularity, and we see 100 new electric vehicle models launching worldwide in this calendar year alone. These new electric vehicles include advanced driver safety and in-vehicle infotainment features that have significantly higher memory and storage requirements. In fact, some of these level 3 autonomous electric vehicles have about $750 in memory and storage content, which is 15 times higher than the average vehicle. Imagine how autonomous vehicles, autonomous agriculture equipment, and autonomous IoT equipment will be able to help reduce traffic on India's roads, improve the crop yields of India's farms, and improve industrial productivity across all of India's factories. We expect memory demand in these applications will continue to increase as these advanced features evolve and proliferate. Over our 4+ decade history, Micron has grown into the world's 4th largest semiconductor company and is a global leader in memory and storage technologies. Our innovations have been at the heart of computing systems for more than 4 decades. Our company is driven by the innovation of our 44,000 people located in 17 countries around the world. Together, that team has amassed nearly 50,000 granted patents, which underpin our technology and reflect our deep commitment to developing solutions that shape the world's future. Our global footprint not only allows us to benefit from scale while streamlining processes and operations, but it also brings together some of the world's brightest talent to work on our most advanced memory technologies. That global team has been a tremendous asset as we move technology forward. Memory is now at the leading edge of semiconductor process and design, and Micron is leading the world in both DRAM and NAND memory. Innovating these new cell structures requires the brightest minds in the fields. Earlier this year, Micron introduced its industry-leading 1-alpha DRAM, the world's most advanced memory node. This advance in technology cuts across both our standard compute DRAM and low-power DRAM product lines. In low-power DRAM, or LP DRAM, used extensively in PCs and mobile devices, the 1-alpha node has enabled us to drop power consumption by 15% versus the prior generation and has delivered great performance efficiency in these power-sensitive applications. With 1-alpha node, we are also able to deliver 40% higher memory density versus our previous generation, a key to personal computing and data center customer application requirements. And in storage, Micron is the only company in the world with industry-leading 176-layer NAND technology in mass production. Advancements in new materials were a key factor to help us maintain and strengthen our ongoing leadership. Our scientists have modeled and tested nearly every element in the periodic table as we innovate new material processes. The leadership here is central to meeting customer demand across all our markets and has given Micron a multi-quarter lead in ramping products built on these technologies. Our leading processes play a role in increasing power efficiency in memory for smartphones and laptops, speeding data access in data center servers, and also providing high density and cost efficiency in solid-state drives for multiple markets. Product diversity is also driving memory complexity. No longer is the lion's share of memory industry revenue driven by a single generation of DRAM modules built for consumer PCs. Micron offers a diverse portfolio of memory and storage solutions to deliver optimal performance across all end markets, including PCs, servers, mobile phones, graphics devices, automobiles, networking, and industrial applications. Supporting all of these diverse end market products requires comprehensive expertise from silicon to end solutions and a large-scale fabrication and assembly and test manufacturing to enable all of these individual memory products. Our broad portfolio of solutions requires complex packaging and finishing that make assembly and test facilities instrumental to our production strategy. Given the multiple disruptions of the last several years, there has never been a greater premium on supply chain diversification. Micron has invested heavily in building a resilient supply chain for assembly and testing our products in multiple sites across Asia, which has enabled us to provide business continuity for our customers. The location and reliability of assembly and test is also critical in ensuring we can serve end customers through any supply chain disruption or obstacle. These sites have become a critical component in our value chain and manufacturing ecosystem. An excellent manufacturing network is an absolute requirement to compete in our industry. Micron manufactures more than 6 billion IC chips every year and turns those into more than 3 billion individual products. Micron is a real manufacturing powerhouse with world-class smart manufacturing techniques deployed across our operations to maximize the efficiency and quality of our production. Our industry also requires constant innovation with a sharp eye toward the future. Our advancements won't have the impact they should unless they are paired with a dedication to sustainability, supporting our communities around the globe and cultivating a diverse and inclusive culture for our worldwide team. Some of the ways we demonstrate our commitment to the global communities we are part of are through our people and our giving and sustainability programs. We are committed to improving our environmental and social performance in operations, sourcing, and across all our products. A critical component of Micron's sustainability strategy is a set of clear and bold aspirational goals that strengthen the link between environmental responsibility and business prosperity. We are focused on becoming a global semiconductor industry leader in emissions reductions, energy efficiency and renewable energy, water conservation, and waste reduction. In fact, earlier this month, we enrolled in Malaysia's Green Electricity Tariff Initiative, committing our sites there to source 100% renewable energy in 2022. Through the agreement, our sites will eliminate about 120,000 metric tons of carbon dioxide per year, the equivalent to removing 24,000 passenger vehicles from the road. Micron's sustainability efforts extend across our complex supply chain with over 9,000 suppliers in 42 countries. Over the past year, we have expanded our supply chain diversity and climate performance efforts while remaining among leading companies in our conformance with industry-wide conflict mineral efforts. Today, we see the opportunity for new semiconductor designs to solve problems that were unsolvable in the past. They remain a very exciting field to work in. And Micron's important work is done by teams that imagine and collaborate on new solutions all over the globe, including here in Bangalore. I'm very proud of what we have accomplished in India and the continued transformation that is happening here. We see growing opportunity in India, both as a region driving new design and innovation, and also as a significant market. As India continues to advance its rapidly growing economy, the technologies I described earlier, 5G, artificial intelligence, edge networks, and autonomous, will play a transformative role. I'm confident this progress will bring about many new opportunities for Micron to partner with Indian technology companies and OEMs. India plays an important role connecting Micron's proud history to our future potential. Our sites here are a key part of our execution engine. Our world-class engineering, design, and delivery teams in Hyderabad and Bangalore will cross the 3,200 headcount milestone this quarter and will continue growing rapidly. In fact, over the last 3 years, we have probably achieved one of the fastest ramps for a semiconductor company on the subcontinent. We expect to have 5,000 team members at our sites here in the next 2 to 3 years. The quality of Indian engineering talent is remarkable, and Micron is investing in it. Our teams in Hyderabad and Bangalore are a key part of our global talent network and play an important role in our innovation engine in the years ahead. Our teams here developed an in-house controller for our flagship mobile storage devices, ramped leading-edge NAND into our 1 terabyte SSD for laptops, and led high-speed analog and mixed signal IP for high-speed DRAM interfaces. Our India team is integral to advancing our vertical integration to develop differentiated solutions which are critical to enabling breakthrough customer innovation. I strongly believe that the best innovation comes from a team that is intelligent, tenacious, collaborative, and diverse. Finding a pool of talent that embodies these qualities can be difficult, but it is absolutely foundational to everything else we do. Our University Research Alliance here in India is at the vanguard of our efforts to identify, reach, and nurture talent early. Our efforts cover research collaborations, course curriculum design, scholarships for underrepresented groups, and internships in our labs. Micron has benefited immensely from the abundance of engineering talent here in India, and we are committed to giving back to expand and enhance the talent pool. I wish the India Semiconductor mission every success toward building a vibrant semiconductor ecosystem that would enable India's emergence as a global hub for semiconductor manufacturing, design, and technology development. A special thanks to Rajiv ji for conceiving and curating the first Semicon India conference and bringing us all together to work towards achieving this shared vision. I'm grateful to the Ministry of Electronics officials, industry associations, and the Semicon India Steering Committee who have facilitated this remarkable confluence of global stakeholders, which I'm certain will catalyze the development of the semiconductor ecosystem here in India. Micron's vision is to transform how the world uses information to enrich life for all. These data platforms can be truly transformative to the human experience, providing better decision-making, more equal opportunities and access, and a safer, more efficient world. The entire technology ecosystem must work together to build systems that are capable of reaching this great future. I believe the potential ahead of us is nearly limitless. The best and brightest across our world continue to invent what didn't before seem possible, breaking barriers to create technology that will help to enrich all our lives. Our ability to better gather, understand, and make use of the data all around us will provide opportunities that were not available and sometimes were not even imaginable just a few years ago. Together, we can achieve this, and the best is truly yet to come. Thank you.
Thank you very much, Mr. Sanjay Mahirotra, for giving us a comprehensive overview of the semiconductor opportunities in the new world order and steps needed to be taken to tap the same. We'll now have the next keynote address also on the virtual mode. The keynote address will be by Shri Randhir Thakur, President, Intel Foundry Services, Intel Corporation. He is leading Intel Foundry Services as an integral part of Intel's IDM 2.0 strategy, and he's an innovator and business leader with expertise in global manufacturing, research, and development. Shri Randhir Thakur has joined us. Now it's all yours, Shri Randhir Thakur. It's over to you. Take it away. Dr. Randhir, kindly unmute yourself. We are trying to, yeah. Sorry for the inconvenience.
Hear me now?
Yeah, we are getting now. Go ahead.
Okay, great. Thank you. I would like to thank Honorable Prime Minister Modi ji, Honorable Minister Ashwini Vaishnav ji, Honorable Minister Rajiv Chandrasekhar ji for the opportunity to speak with you all today. I'm Randhir Thakur, President of Intel Foundry Services, and I have spent more than 30 years of my career in the exciting field of semiconductors. This is a significant moment as we gather to witness the launch of India's semiconductor strategy and policy. I'm honored to share this stage and screen with so many of my industry peers and colleagues who recognize the potential and the importance of this work to India's future. Today, I'm speaking to you from Silicon Valley, and my aspiration is that, as Honorable Minister Ashwini Vaishnav ji has said, that it is not too far in the future when we will be coming together to celebrate Silicon Himalayas. In today's digital world, a domestic semiconductor industry is critical to economic growth and security. It is also central to geopolitical dynamics. India today is a digital nation with much of the foundation in place to become a semiconductor nation. Intel has been a partner to India for over 30 years, and we are thrilled to be with you on this journey. Today, I would like to share our perspective on the powerful and remarkable commitment that India has made, the opportunity you have in front of you, and the critical steps needed to be successful as a semiconductor nation. Every aspect of human experience is becoming more digital, which is driving an age of sustained long-term demand for semiconductor. We see it all around us, from autonomous vehicles and artificial intelligence to cloud computing, pervasive, always-on connectivity enabled by 5G and beyond. We believe this will create greater than $1 trillion of opportunity. At the same time, the world needs more balanced and resilient supply chains to be successful. Every industry is now a digital industry, fueled by the reliable delivery of semiconductor chips. During the pandemic, we have seen the impact of supply disruptions. That has shown us how entire value chains and economies are so dependent on having a robust and globally secure supply chain. As our CEO, Pat Gelsinger, likes to say, semiconductors are the new oil in this digital age. Semiconductor manufacturing will become more important than oil reserves in defining geopolitics in our digital future. Unlike oil reserves, where we do not choose the location, we can flourish and lead in semiconductor manufacturing at a place of our choosing. At Intel, we have focused on creating a globally diverse manufacturing footprint to meet the demands of the future. Today's concentration of semiconductor manufacturing in a few localized regions will not be sustainable in the long run. This has led global leaders to look to the policies and investments that will position their economies to succeed in the coming decades. I'm really excited that honorable government, in its wisdom, has approved a comprehensive program to catalyze India's semiconductor industry. Congratulations to all of you on this important step. You are demonstrating leadership and dedication, making rapid progress while much of the world determines their next steps on semiconductors. Your efforts to develop the semiconductor manufacturing ecosystem and insert public market capital for technology startups is exactly the flexibility and agility that is required to succeed in this industry. The collaborative approach shown in the creation of the policy and the advisory committee, as well as this very conference, is a testament to the partnership focus and open-mindedness that you are bringing to this cause. Reading the details of your mission, it is clear that the policy was thought through by industry experts, and it has been met with immediate enthusiasm. Industry leaders have taken notice of this ambitious plan, as shown by the supportive audience and speakers here today, and the positive ecosystem response you have received. Never before has the semiconductor world seen a country coming together with such a compelling vision. Truly, the stars have aligned so well. The Honorable Prime Minister and his cabinet are so clear on the importance of this strategy. And I have to say, in speaking to all of them, they are very knowledgeable about the semiconductor field. Time is of essence. Given the rapidly evolving global political situation and India's significant domestic demand for semiconductors, this approach is positioning India well to move quickly and intentionally. And as the Honorable Prime Minister says, now is the time to invest in India, and it shows. Let us talk about India's journey And I divide it in all these different stages. India has a long-standing track record of leadership in technology and engineering transformation, which has prepared it well to take this leadership role in the major digital inflection happening today. Honorable Prime Minister has spoken about India's history as a Vedic nation, saying, on one side we invented zero, while we also explored the idea of infinity, laying the foundation for our modern day computing. Post-independence, India progressively became an industrial nation. In the 90s, India successfully established itself as a software nation, harnessing young engineering talent to position the nation as a software, IT, and business process outsourcing hub to the world. This began India's successful history as a trusted supply chain partner, which continues till this day. In the last decade, India has led as a digital nation. India has the third largest startup ecosystem globally and one of the world's largest pools of technology and engineering talent. The scale of digital adoption is extraordinary, reaching mobile connections, internet users, and digital identities of over 1 billion people each. India is now positioned to become a semiconductor nation at this critical market inflection point. The capabilities that India has built in supply chain partnerships, innovation, entrepreneurship, and talent are the right tools for the next step. The world will look to India's leadership and contributions here, and it has so many times in the past. In this context, we see a world of opportunity for India moving forward. Looking at the semiconductor value chain, we see that India has a footprint today in several critical steps: in IP, in design solutions and services, and in ODM and board and systems manufacturing. This is solid foundation on which to build. To become a semiconductor nation, India must capture a broader swath of semiconductor value chain. To do this, India can build on the strength of its ecosystem and expand its current offerings. This means moving beyond IP and design into additional areas of focus within semiconductor manufacturing, including wafer fabrication, package, and test. This is significant opportunity for India. Developing a comprehensive portfolio of products and solutions will enable India to drive economic growth and strengthen its internal resilience. Given the track record of developing digital industries, India is well positioned for success in building out this value chain. It will require a diverse set of players drawing upon India's thriving startup community and collaboration with global corporations. And ultimately, this will need to be at scale to address not only the domestic, but also the global market. Again, I congratulate the government for leading India on this important journey. This is a considerable growth opportunity, not only for the nation, but for all the ecosystem players. While India has made a strong start, becoming a semiconductor nation is a long road. And both Ashwini Vaishnavji and Rajiv Chandrasekharji have made it very clear that please not only tell what is good, but also what needs to improve so that we can move faster. As I mentioned, India will need to attract and support a diversity of domestic and multinational industry players to build out the semiconductor value chain. From my experience, let me share what the industry looks for when evaluating greenfield opportunities. We seek a combination of factors: technology partnership with industry leaders who bring expertise in the latest innovation, reliable infrastructure to support the high-performance manufacturing operations, as well as knowledge infrastructure policies like technology parks. access to the semiconductor supply chain for equipment and raw materials, highly skilled labor force to support design, assembly, and manufacturing capability, a regulatory environment that is conducive to business and investment, trade policies that encourage multinational companies to expand capabilities and enable global competitiveness. Some of these areas are stronger today, and some need to be tailored to serve a thriving semiconductor industry. Though it will take time, it is strategically important to consider these factors. At the current pace, and with the momentum created by ISM, I'm confident these challenges will be addressed swiftly. Now, I want to talk a little bit about India, about Intel in the India context. At Intel, we have been at the forefront of the semiconductor industry from the beginning. We have led it through multiple inflection points and technology transitions. We have seen the birth of the integrated circuit with the Intel trinity of Gordon Moore, Robert Noyce, and Andy Grove. Together, they paved the path towards PC, internet, server, cloud, and everything electronic we see today. India's own Vinod Dham, and as Minister Chandrasekharji rightfully pointed out, the father of Pentium, laid the foundation for Intel's revolutionary line of microprocessors. He made seminal contributions to the semiconductor industry as the lead on Pentium processors. And our journey at Intel continues. Most recently, after Pat Gelsinger rejoined Intel, he launched the IDM 2.0 strategy. Intel Foundry Services is an integral part of the journey, where we are providing world-class foundry services to meet the incredible global demand for semiconductor manufacturing. I'm privileged to lead this business and have been energized to see the support from our customers and industry partners. The urgent need for more semiconductor solutions only reinforces the importance of the work India is planning for this time. Now let me talk about India specifically. Intel has a long-standing relationship for more than 30 years with India. Just to share with you some highlights, Intel founded one of the first at-scale design centers in India in early 2000s. We have now grown to 28,000 employees in India. We have invested more than 7 billion in our sites across India, with campuses in Bangalore, Hyderabad, and other places. Additionally, India is home to Intel's largest design center outside of the US. Intel India plays a strategic role, and the team has made significant contributions to our technology and product leadership, including cutting-edge work on AI, 5G, and autonomous driving. We collaborate with more than 70 startups across India through multiple programs engaging with industry, academia, and the government. In 2021, we launched the Plug-in Alliance with Sign IIT Bombay, a first-of-a-kind alliance in India promoting the Industry 4.0 transformation. Through another startup programs, we have supported Coconix, a unique company that manufactures IT products under the Make in India initiative. And we have worked together on social, educational, and environmental initiatives, such as our AI for All digital readiness program. Together, Intel and India are creating innovations to impact the life of every person on the planet. And that's Intel's mission. Going forward, Intel is committed to India for the growth of the semiconductor market. We have embraced the open IP ecosystem in India, including recently joining RISC-V International. A thriving open ecosystem is critical to support the entrepreneurship and startup culture that India will require to build out the semiconductor industry. We have already launched public-private partnerships to develop solutions using RISC-V with CDAC, Darby, and India's outstanding IIT educational system. Our open culture of collaboration and innovation will catalyze the growth. We are working with multiple private sector companies to make Intel Foundry Services India's platform of choice, really the platform of choice. We are accelerating the growth of this robust and growing open ecosystem with a $1 billion innovation fund that is directed towards funding startups we can enable through Intel Foundry Services. The combination of open IP, open source software, our open foundry platform, and our ecosystem investments will exponentially accelerate the growth of semiconductors in India. We look forward to partnering with India on the journey to becoming a smart semiconductor nation. And in closing, today we have all come together to celebrate a decisive step the Honorable Prime Minister and his cabinet have taken. The India Semiconductor Mission is an admirable and important vision to build a vibrant semiconductor industry supported with a resilient supply chain, a robust ecosystem of partners, and homegrown IP. This is a critical step to protect India's Industry 4.0 journey, as well as its continued leadership on the global stage. India's journey to become semiconductor nation will enable self-reliance in the most critical industry of the 21st century. It will further strengthen the nation to become economically stronger Bharat, geopolitically resilient Bharat, and most importantly, Atmanirbhar Bharat. At one time in history, Charkha transformed our nation. Today, chips have the power to do the same under the leadership of Honorable Prime Minister Modi ji and his esteemed cabinet. Jai Hind, thank you.
Indeed, ladies and gentlemen, Semiconductor Bharat, Atmanirbhar Bharat. Thank you very much, Sri Randir Thakur, for your keynote address. After two virtual keynote addresses, ladies and gentlemen, we are all now set for a physical keynote address. We have Mr. Jim Keller, President and CTO of Tenstorrent, all set and raring to go, a dynamic technology leader in computer architecture, processor design, and AI/ML. Jim is currently the President and CTO of Tenstorrent. Before becoming a part of Tenstorrent, he was Senior Vice President of Silicon Engineering Group. So ladies and gentlemen, let's give a round of applause and welcome Mr. Jim Keller.
All right. Yeah, I was invited to come talk at Semicon, and I didn't know that much about it, and I thought I might talk about AI and processor development, RISC-V, and then I saw the brochure, and it said I was going to do a talk about India leading chip design for the world. And so I threw out my old presentation, and I started thinking about, what would I say? And a few people know me, and I'm opinionated, apparently, and Ashwini invited us to be blunt. And so I started thinking about that. And just for some background, I've been working with India teams for about 10 years. And it's good to be back. I haven't been here for 2 years. Jay is here. She worked with me at AMD. Some of my friends from Intel are here. And we did some great things, and I think for some reasons. And I just wanted to talk about some of those. Because to lead, you have to win. To win, you have to be great. And you can't just goof around and have a lot of seminars, because that's not going to do it. So I thought I'd hit 3 big points. But what drives our industry is Moore's Law, more transistors. More transistors means more complicated computers, faster computers, more applications, maybe bigger ones, maybe smaller ones, right? And it's been relentless. And it's been declared dead a lot. I've been hearing it was dead for 30 years. And at some point I thought, it can't always be dead in 5 years, right? Maybe they're just wrong. So I've assumed they're wrong, which has been useful. So I'm going to talk about 3 different things. Skills, setting goals, and these are goals to win, right? And then the attitude. I'll just have one slide at the end about like how do you have the right attitude to do the right thing? And whenever I give talks, I've been in India for about a week now. I talked at the IEEE Society in Bangalore. I give a talk to students at IISc. I talked to some industry leaders and some friends of mine. I was up in Hyderabad and I gave a talk at Invicus, who's been a partner for Tenstorrent building chips, and they've done a great job. And each time I noticed the intensity that people want to learn. And I've talked to some professors, some people who do teaching both in, that was really cool. And we took some photos, and I have them sprinkled in here, shameless promotions for my talks. But what I really noticed when you talk about technology and how to do technology, people really lean forward. And I was talking with one of the professors about this idea of, like, universities often teach too much theoretical stuff. And then training institutes focus on CAD tools and tools of the day. But what makes a great engineer is more than that. And we came up with the 2x2 matrix because I'm an engineer. Like, there are deep things and there are practical things. And then there's real knowledge, but then there's problems, right? So the classic big university teaches deep knowledge, math, chemistry, physics. And by the way, they're really important to be a great engineer. Training institutes and engineering training programs, you know, you start with electrical engineering and computer science, but then you go to coding boot camps, you go to CAD tool training, right? But if you over-index on that in a changing business, the students won't have that deep knowledge to continue. One of the most important things students can do is be in a lab, try to build something, and it doesn't work, and then they have to figure out what to do and debug it. This is really important. And then when that solution is bigger than the local problem, we call that invention. We've been inventing new computers for years. I had the unique opportunity and good fortune to talk to Swamiji yesterday. And he told me a lot of things, but I thought I'd share 2 of them. He said, please make the world a better place by bringing people together. Maybe tear up a little bit. It's a beautiful thing. I hope he can do that. But the other, he said, be like a bumblebee and go to each flower and take a little bit. So when we teach our students and our engineers, each area, make sure we focus on that. I think this is really important. One of the things we do when we're great engineers is we solve the problem of complexity, right? You don't jump to the mountain in one jump, you have to walk up. You don't learn to be a great engineer by taking the hardest course, you work your way there. And I realized one of the things is, I've solved some hard problems, I work with teams to solve hard problems. You have to reduce the complexity to the point where the engineers can get the work done. And complexity means there's too much crap in one place that they can't solve, and then they struggle. And the architecture of solving from complexity, I saw this network stack in the 80s, and it blew my mind. Because instead of saying, here's TCP/IP as this big thing, they turned it into multiple layers, divided and conquered that, so you could innovate at each separate layer. And that changed the world, right? And whenever we properly apply this lens, and I tell students and young engineers, if your problem's too hard, is this abstraction layer done properly? Do you know which part you're in? Does your team and leadership know what's going on? Because this is a really hard problem. Most projects failed because they haven't refactored this properly and solved it. And you can't just solve it by putting more people on it. All right, I'll talk a little bit about goals. So, preparing for this talk, I talked to a bunch of people, and I heard that India wants to be best in class. They want to be lowest cost. They want to have local control and supply chain. They want to train and own, and have world-class engineers. These are 4 different things. And if you try to do all of them, you'll fail. Now, maybe this company is world-class, maybe this one's low cost, maybe there's a way to get supply chain. Supply chain is really complicated. Intel, big companies tend to think of world-class technology as leading node, but most of our products don't need that. I was telling a congressman in the US, they want to invest in high-end technology. And I said, what, so we can all have a new iPhone? What about the technology chain that lets us build refrigerators and air conditioners, right? That generates jobs, that generates technology independence. It's a complicated thing. You have to pick which one you're doing. And maybe, I'm looking at the ministers here. By the way, thanks for inviting me. Make sure you're looking at each one of those different areas. And the next one is, make sure you know where you're at, right? This is the iron law of the S-curve of the world. You start in searching mode, trying to figure out what to do. Somebody discovers something like maybe the internet, right? And then there's a ramp. And then that technology matures, and then it inevitably fails. There are no rotary phone engineers anymore, right? The world changes. If you're going to lead, you need to lead from the pathfinding or the ramp phase. The mature environment, they've already squeezed the nickels out of it, right? So if you're going to lead and do something new. Now, there's a new way to do something lower cost that we think is mature. Innovation shows up everywhere. But be clear where you're investing. Don't invest on the end of the curve. Steve Jobs one time said, this curve is real. To get to the next level, you have to start the next curve. And when you start the next curve, it's actually worse off than the optimized mature business. But from there, you can go ahead again. And we do this in CPU design. You tweak a CPU for 10 years, there's nowhere to go. You make a new one, it's actually worse. But the new one has the opportunity to grow. So I've been working on computers for 40 years. And I knew Gordon Bell, who was the CTO of Digital, and he was a great guy. But he also defined Bell's law. He said every 10 years, we have enough transistors to build a new kind of computer. Mainframe, mini computer workstations, PCs, mobile. It's been a fascinating journey, and I worked on mini computers, workstations, PCs, and mobile. And now I'm working on AI. And that keeps fostering new innovations. And what's happening today is there's a new kind of computer coming along we call AI. But there's also a revolution with RISC-V, which is a new computer architecture which gives us a chance to go do new things and not work off a mature base. And it took me a little while. I was thinking about this. All these computers essentially run C programs, and Zen 3 is a great example, right? Mainframes ran assembly in C. So did mini computers. It's kind of wild. I personally spent 40 years making C programs run faster. Sometimes I don't know how I'm going to feel about that in a few years. But that took us from non-pipeline to pipeline to superscalar to out-of-order computers. And each one of these innovations changed what kind of problems we can solve. I want to talk a little bit about RISC-V. I realize I have your picture right here in my slide. Yay. I think that was from a tweet, must be today. Unless you change your shirts as often as I do. By the way, I was told that this is a formal event, people would be wearing suits, and I got a little nudge, so I went out and bought a new t-shirt. And I think it looks great, but yeah, that's what I'll do for a country as great as India. So RISC-V is a beautiful thing. It's a new computer architecture. It's a great definition. x86 and ARM are slow to change. We're building an AI processor. We asked the guys at ARM, great guys, if they could add some new floating point data types for us, and they said no. They don't see the market need. And I thought, I'm the market need. I just asked you. With open source, you can add things. I know David Patterson and Crystal pretty well. They did this out of passion so students could have something they could go change and innovate, and I think they succeeded past my wildest dreams. And I think change in the next 10 years is going to accelerate, and you want a platform where you can do that. And then these companies here, Sci-Fi, Revos, Tenstorrent, Calico, Etana, they're actually all in India already. And the India government has said they're going to go support this. So this is a fantastic thing. We're designing a new from-scratch processor. We just opened up an office in Bangalore. We got our incorporation final yesterday. So Tenstorrent India Limited is a real thing. Really excited about that. And I've been thinking about this layered abstraction stack, applications architecture, reference model, performance model, microarchitecture, verification, implementation. This is a hard one understanding about how to build processors. And with RISC-V and our new team, we're going to go really take a new shot at this to build a better processor. And this is the first processor we're building. We've already hired 15 people here. And we did a little check. It's from 8 different companies, some US-based companies, but some India-based companies. So we think we're going to have a really diverse team, and there's going to be an opportunity to do some great things. The innovations happening in RISC-V are going to be partly at the implementation level. So our team, we're going to build a machine with provable interfaces, really scalable definitions. The modern CAD tool suite lets us build a processor, not just optimized for one thing, but lots of flexibility. We already added new data types for AI, which is going to make performance better. And then we're going to build AI processors and CPUs together in the same silicon where they can talk. And there's 2 papers recently, one from Microsoft, one from Google, which talked about how AI and general purpose computing talk together. This is really exciting, and I think we're going to learn a lot on this. The other thing Moore's Law does for us is unlocks the ability to build the next computer, right? When you had a few transistors, you couldn't build even a pipeline computer. But as we got more transistors, the number of transistors per processor goes up. The first machine I worked on was a VAX 800. It had about 100,000 transistors in it. Modern CPUs, 100 million is a common number. So we have pipeline out of order, GPU shaders where you could run a program on every pixel. And then multi-core processors. When I first proposed K8 at AMD, we're going to do 2 and 4 processors on a die. People thought that was crazy. They're so big. And would you rather have a bigger processor? Now we think 64 is a plausible number. We're just hitting the number of transistors to unlock AI. Jeff Dean gave a talk last year at DAC that was brilliant, and he said when they first got AI algorithms to work, they thought if they could get from 1 to 64 processors, they could really run it faster. And then they realized it was running 1 million times too slow. 1 million times too slow. So modern big language models run on thousands of GPUs for a month to train it. They're still 1 million times too slow, but they're now fast enough to actually do that, and the innovation in space can be really big. We made this slide when we raised money, and I've told people, quoting Andre Garpathy, when you're raising money is a really good idea. So any startup people here, follow him, quote him. But what he said, this is really great. Software 1.0 is when people write programs. They write essentially the way you think. Do this, then do this. If this, do that, right? And software 2.0 is actually take data and information to train a network to make an association. The programs are very, very different. And then I'm not really an AI person. I'm a CTO of an AI company, and for the last year I've been reading a couple papers a week. And I noticed they all write in high-level math, which I vaguely understand from 40 years ago. But the good news is the AI researchers are pushing the envelope of the math to describe the relationships between data. But that translates into simple equations that computer guys like myself know how to speed up. A equal B times C plus D. I'm not kidding you. Almost all the hard math turns into something like that. This math has established the understanding about what the data is doing, but the AI programs themselves are actually kind of small. Hundreds of lines of codes to do a model that runs in thousands of GPUs for a month. The programs make a graph, and then our job as an AI company is to translate that graph So we did the same sequence of events, which is take the architecture stack, and then we translated that into a complicated software stack. So PyTorch and TensorFlow are open source languages for AI. TVM is an intermediate representation which we use. Then we generated something that expands the graph, puts in autograd, lowers the graph, and then finally places that on a large array of processors. And our innovation is you can write the graphs you want, and we can run that automatically. And then we paired that up with simulators so we can simulate at each level and understand it. And here's an example of what graphs mean. So AI is built on a small number of primitives, but when the programmers write the code, there's a huge number of different graphs, and this turns it into a really hard problem. Our founder Luigi said, when he started working on it, he knew it was hard, but then we found out it was way harder than that, because the combinational complexity from a small number of operators and a small number of graph operations turns into a huge variety of code. The way our computer works is you write code on the left. That's part of BERT, which is a popular language model. We translate that into a graph, and then we lower that into multiple processors, and then we lay that out on large numbers of AI processors. Our chips have about, shameless plug for Tenstorrent, 100 processors or so in the first generation. We can hook up thousands of those together. So this is an amazing thing. One program through a compiler to go engage 1,000 processors. We're building this today. The first 2 generations is a partnership with a company called Invicus. We designed the AI hardware. They did the back end. Their execution was flawless. This is a beautiful thing in the modern age. Our chips powered up and ran the first time. Right. We've integrated in RISC-V processors. We're starting to use AI to build AI, and there's a picture of our CPU team that we just started hiring in Bangalore. It's really exciting what's going to happen next. Here's a picture of some computers. It's kind of wild with all this change underneath. We're building a 4U server with 8 PCI Express slots, 2 chips on each one. That's the first version. The second version on the left is an AI data center with 2,000 processors in it. We built the first one in Austin. We're now pursuing a plan to try to build the next one here in Bangalore. We started hiring open source software people, open stack software people. Some of them are right here in Bangalore. So this is going to be the next really big step for us. I just want to circle back to the other component of winning. You have to own the goal. One of the big transformations I did when I led teams here is don't treat the resources as resources.